Let's quickly do a few more confidence interval examples for proportions. Here you can see that the number of people I talked to is 3,005, and here's the number of people that said that they expected to work past the age of retirement out of this 3,005. Okay, so here the sample proportion you can see is just the number of successes or the number of people that said yes out of the total number that I asked. Here we're changing things up. We want to be 99% confident. Okay, so here how does that change things? In the middle, instead of 0.95, we have 0.99, which means we have 1% error to share between both possible tails. Okay, so here this is going to be 1% divided by 2, that's alpha over 2, which is 0.005. In the Z table you can look it up. Okay, it's not going to be perfect. Okay, so here's an example that's not perfect. You can see I've drawn a little picture. It's in the row negative 2.5 and in between 0.07 and 0.08. Okay, let's have a look here. We said it was in the row negative 2.5. As you can see, when I'm scanning across, here, in between these two. 0.005 is somewhere in between these two values. Okay, so when I'm using the table like on your final exam, I might use a Z value of negative 2.575. Just split the difference and go right in the middle there. So I might do that. So there's the lower limit, or the lower Z standard deviation. Here's the upper Z standard deviation. So I've got that value. I can plug it in and I'm fine. Also in Minitab then, when I go to basic statistics, one proportion. Okay, here in this particular case, I've got 1683 out of 3005. Going to options, here's where I want to make sure my confidence is whatever it's specified to be. So this is 99% confident, not equal to sign, and again using the method of the normal approximation. Okay, so here is my 99% confidence interval. Okay, what does it mean? I'm 99% sure or 99% confident that the proportion of all Canadians between this age and that age who expect to work past retirement is between this value and that value, or 53% and looks like 58%. So can you infer that P may be 0.54? Okay, so here's my interval. 0.54 is inside the interval, so yes, it seems like it's theoretically possible that the proportion really is 0.54. It's in between my believable range. Is it true that the proportion is less than 0.6? Here's 0.6. My entire interval is below 0.6 or 60%. So yeah, it appears that P is truthfully smaller than 0.6. At least I'm 95% or 99% sure it is. Okay, so here my whole interval is completely below that. I believe that this statement is true. Okay, let's just quickly see another example. You've seen how to do it several times, so you can probably do it. Here, just a quick example where I get a confidence interval. I'm 95% sure that the proportion is between 0.13 and 0.29-ish. Okay, so here I've drawn my interval out. Is the proportion actually 0.2? Well, 0.2 does fall inside my interval, so yeah, it's possible that the actual proportion is 0.2. I believe that it's in between 13 and 29, so yeah, 20 is possible. Do you believe that the proportion is greater than 0.25? Okay, so here when I draw this, I've got 0.25 here, and it happens to be inside the range. Okay, so is P greater than 0.25? The answer is I don't know. I don't think so. Why? I mean, there is certainly some amount of our interval that claims that it is above 0.25. However, there is some amount of our interval that says no, it's probably less than 0.25. So overall, we would say no, it doesn't appear that P is significantly greater than 0.25 because it's, we're not saying if P is in here or if P is in here, we're just saying P is inside of this interval. So we cannot say that P is actually greater than this. If you wanted to say something like that, if you wanted to see that, then you would expect if P really was greater than 0.25,